conditional probability. It's just another step in our probability lesson, and let's jump into it. So it's supposed to say conditional probability right here. So conditional probability, first thing we're going to look at is a dependent event. So dependent event is the outcome of one event does affect the outcome of another event. So that means like if I reach in and grab a marble out and set it out, then I did not replace that marble. So that means it's going to affect the outcome of another part. So dependent means it's depending on something else happening, okay? So replacement means after an event occurs, the probability resets so that the number of total possible outcomes does not change. So that means if I end up resetting the situation, that's known as replacement. I'm replacing the total amount. So always assume that the desired outcome is selected first. Without replacement means I'm going to take out and then I'm not going to replace it. So after an event occurs, the probability changes so that the number of total possible outcomes changes. Always assume to get the desired outcome is selected first. Okay, so conditional probability basically means that if there's a condition happening. So like the thought of this happening before that happening, there's a condition to it. So it's conditioned to happen before that happens. So basically the way I do that and the way we read this is the probability of A given B has already happened. That's what that means. It's given. So right now you're going to take the desired outcome of A. So like if you need to find the probability of A happening multiplied by the desire of B. So this is with replacement if that was to happen, okay? The probability of A given B happening, and this is an example of not replacement, or it means I'm taking it out, okay? It means it's I'm basically taking it out. So I'm going to take the desired outcomes of A, and then if you look, I'm going to take the desired outcomes of B, but the total outcomes is going to change on the bottom, so I have to subtract out what I took out, if that makes sense. So I'm going to take this example or take this idea and apply it to my examples down here. Let's move to example number 1. So on example number 1, it says there's a bag of marbles that has 6 red, 8 blue marbles. If you randomly select 2 marbles with replacement, this is huge, find the probabilities, okay? So right now, we need to find the probability of red given blue has already happened, okay? So with this being said, we're gonna find the probability of red and blue. Remember, it's with replacement, okay? So right now, the probability of me getting red, there's 6 and 8, which means there's 14 total, and there's actually gonna be 6 red. So there's a 6 out of 14 chance. So that means I'm gonna reach in, I'm gonna pull out a red, and then I'm going to put it back, okay? Then what's the probability of me getting a blue? So right now, the blue is going to be 8 over 14. And then all I got to do is multiply across. And then, so 6 times 8 is 48. And then 14 times 14 is going to give you 196. And then 48 divided by 196 as a decimal is going to give you 0.244, which is going to be a 24% chance that this is going to happen. Okay, now what's the probability of me getting a red and a red? Okay, so I know there's 6 red, 14 total. So that means I'm going to get a red, and then I'm going to put it back, and I'm going to pull out another red. So what's the probability of me drawing 2 reds in a row? So 6 times 6 is 36. 14 times 14 is 196. 36 divided by 196 is going to give me 0.1836. Which is going to turn out to be about an 18% chance of this happening, okay? Now what's the probability of me getting a blue first and then pulling out a red, okay? So I'm basically doing the same thing again. Remember, it's with replacement. So blue is going to be 8 over 14. Red is going to be a 6 out of 14 chance. When I multiply it across, it's going to be the same as the top. And then it's going to come out to be a 0.244 chance, which is going to give me a 24% chance. And then lastly, what's the probability of me getting a blue and a blue, okay? So that means I'm reaching in, pulling out a blue, putting it back, reaching in, trying to pull out another blue. What's the probability of me getting that? So blue was 8 over 14 on both of these. So that's the probability of getting a blue and getting a blue. So 8 times 8 is 64. 14 and 14 is going to give me 196. So 64 divided by 196 as a decimal gives me 0.326, which is going to round up to about 33% chance. So remember, this is without replacement, meaning I'm not putting it back in, Okay, so let's jump over to example number 2. Look at example number 2. So it's basically the same situation on example number 1, but this time we are not replacing, okay? So right now, what's the probability of getting a red and then a blue? That's basically what that means. So right now, the probability of me getting a red first is gonna be 6 out of 14 again. But the thing we have to understand is I'm taking one of those total marbles out. So 14 minus 1 would give me 13, and I took out a red, not a blue. So that means to get a blue, there's gonna be 8 total left on top. Okay, so that's gonna change the probability a little bit. So 8 times 6 is gonna give me 48, and then 14 times 13 is gonna give you 182. So 48 divided by 182 as a decimal is gonna give you 0.263, which is gonna be a 26% chance of that happening, okay? So now what's the probability of getting a red and a red? So you really gotta pay attention here. So I know the probability of me getting a red is a 6 out of 14 chance, but now we have to understand I'm taking out a marble, and that marble I'm taking out is a red. So I have to subtract from both of those. So it means now there's 5 total reds out of 13 total in my bag. So that means 6 times 5 is gonna give you 30, and then 14 times 13 is gonna give you 182. And then 30 divided by 182 as a decimal is going to give you 0.164, which is going to round up to 16%. Okay? So now what's the probability of me getting a blue than a red? So right now we got to think. Probability of me getting a blue is an 8 out of 14 chance, right? Okay? So if I reach in the bag, pull out a blue, they're taking one marble out, so that means there's 13 left, but there's still 6 red left in the bag. So 8 times 6 is going to give you 48, and then 14 times 13 is going to give you 182. So 48 divided by 182 is still going to give you that 0.263, which is going to round up to about 26%. Okay? And then lastly, what is the probability of me getting a blue and then a blue? Okay? So if I reach in and get a blue, there's an 8 out of 14 chance. So if I take out that blue, remember, I'm taking out a blue and taking out a marble, so I'm taking out 1. So I gotta subtract it from both of these, depending on the situation. So that would be a 13 out of 7 chance. So 8 times 7 is gonna give you 56. Then 14 times 13 is gonna give you 182. 56 divided by 182 is gonna be 0.307, which is gonna round up to about a 31% chance. So the thing you have to understand is you gotta understand the situation. What am I pulling out? And then what do I have to subtract? Do I have to do it from the bottom and the top in the situation? So let's move on to example number 3. So look at example number 3. It says there are 16 students in Mr. Tuff's math class. 4 friends, Chad, Alex, Chris, and Dustin are all in the same class. If Mr. Tuff randomly selects 2 students without replacement to answer a question, what is the probability that Chad and Dustin both have to answer a question? So the thing you have to look at is without replacement. That means he's not gonna choose the same person again. So remember, you're doing desired outcomes over total outcomes. So right now we wanna get Chad first, okay? So that means there's only one Chad inside that class, I think, okay? And there's 16 total students. So there's a 1 out of 16 chance that I'm gonna pick Chad, okay? So now I'm picking Chad, that means I have 15 students left. So that's what goes on bottom is 15. And there's only one of those Dustins in the class. So there's gonna be a 1 out of 15 chance that I'm gonna pick that dude. So 1 times 1 gives you 1. And then 16 times 15 is gonna give you 240. And then when I do 1 divided by 240 as a decimal, that's gonna come out to be 0.0041, which move that decimal over 2 spaces is gonna give you a 0.4% chance. So that means if he was to randomly select students, there's a 0.4% chance that this combination of those 2 friends is going to happen. Very low chance of that happening, okay? Let's move on to example number 4. All right, now in example number 4, it says a random number generator is used to select numbers from 1 to 20 without repeating. So that means without replacement. It's basically not gonna pick the same number twice. Any number twice, we need to find those following probabilities here. So what's the probability of getting an even number? Well, out of 20, there's 10 even numbers. So that means there's gonna be a 10 over 20 chance that I'm gonna select an even number. So remember, this means given, it's already gonna happen. So that means I'm gonna take out that even number, okay? So that means there's only gonna be 19 numbers left. And then to get an odd number, there's actually 10 odd numbers as well. So that means 10 times 10 is gonna give me 100, okay? And then 20 times 19 is gonna give me 380. And then if I do 100 divided by 380 as a decimal, that's gonna give me a 0.263 chance, which is gonna round to about a 26% chance of that happening on the number generator, okay? So let's move on to the next one. So what's the probability of getting a number greater than 15, okay? So 15 all the way to 20, that means there's 5 numbers there. So there's a 5 out of 20 chance that you're gonna get a number greater than 15, okay? And then a number less than 3. So that means there's only 2 numbers less than 3, but we have to remember I took out this number, so that means there's only 19 numbers left. So 5 times 2 gives you 10, and then 20 times 19 gives you 380. And if I do 10 divided by 380 as a decimal, that's gonna give me a 0.026 chance, which is gonna round up to about a 3% chance of that happening, 2 decimal places over. Very small chance of that happening, okay? Now let's look at the last one. So the last one says getting an even number less than 8. So there's 2, 4, 6. Those are 3 numbers that are less than 8. So there's a 3 out of 20 chance of me getting that number. And then remember, I'm taking that number out. So that means there's only 19 numbers left. Now what's the probability of me getting an odd number greater than 12? So we got 3, 5, 7, and 19. So that's 4 out of 19 chance of that happening. 3 times 4 is gonna give you 12. 20 times 19 gives you 380. And whenever I end up dividing these, so 12 divided by 380 is gonna give you a 0.031 chance, which is gonna round up to about a 3% chance of that happening, okay? So take this concept, remember, you gotta understand if it's with replacement or without replacement, and that's gonna help you to find those probabilities. So holler at me if you need any help, and good luck on your skill check, guys.